Hello class, welcome to the Geometry Chapter 10 review video. This chapter was all about circles, and I know that some of you can relate to the picture in the upper left hand corner about the circle of trust and how you feel outside of it because you hate circles. So we are trying to avoid all of these situations that are listed on this first slide. But I know that tests can be overwhelming, so let's study so we don't feel as overwhelmed. Lesson 10.1 was all about arcs and sectors. The first thing that you learned about was arc measure, and the way arc measure works is if you have a circle and you have a central angle with the vertex of the angle in the center of the circle, whatever your angle measure is, that's what the arc measure is. Okay? The only time that changes is when your vertex for the angle is not in the center, and we'll talk about what happens then later. Okay, so that's arc measure. Arc length, we learned two different things. We learned about degrees, and when we have degrees, the way that we solve for arc length is arc length equals the number of degrees over 360 times our circumference, which is 2 pi r. So you need to make sure you memorize that. Just remember, number of degrees over 360, because that tells you how much of the circle we're looking at. And then this is your circumference equation, which you've been using for years. But for whatever reason, you guys get overwhelmed and totally blank on what the circumference equation is. Now, we also learned about something new called radians. This is what we're going to use when I don't give you degrees. I usually give you something that looks a little goofy. It'll look like 3/2 pi, and you look at me and say, what on earth is that? And then I remind you, back in 10.1, I taught you what a radian is. So go back to that video, go back to your notes, relook at that. But the arc length for radians is when you take theta. So remember, theta is that Greek letter that we're going to use to represent that angle. And you do theta times the radius. Usually when I give you something like that, I'm asking you to give me an exact answer. So let's say our angle was 3/2 pi and our radius equaled, let's say, 4. I would do 3/2 pi because that's my theta times 4 is my radius. And those of you that are looking for a picture, there is no picture. I'm making this up as I go. 3/2 times 4 becomes 12/2 pi, or 6 pi as an answer. Okay, so that's an exact answer. That means I don't want you rounding to anything. I don't want you plugging that into your calculator to get a decimal. Make sure you're reading directions, because on the first section, there's about half that are exact answers and half that are round to the nearest tenth or hundredth. Make sure you're reading directions. I know you like to skip that. All right, so sectors, if you can do arc length, you can do sectors. The area of a sector is the number of degrees over 360 times pi times radius squared. Remember, pi r squared is, again, another formula that you've been using to find the area of circles for many years now. Don't forget what it is. A lot of you keep forgetting, like, how do you find the area of a circle? And I look at you and I say, seriously? You've been doing this for years. Okay? Don't make me think seriously as I grade your test. Also, n over 360, notice that that's the same as what we used in arc length, because that tells you how much of the circle we are looking at. Lesson 10.2 was all about lines tangent to a circle. So remember, tangent means that it meets your circle at a 90-degree angle. So when I give you a triangle like that, you can do Pythagorean theorem and solve for different lengths. Don't forget that usually you have a radius and a radius that you can use to solve your right triangles. The other thing you need to remember with tangent lines is if you have two lines that are tangent to a circle that meet at the same point outside of the circle, so in this case that's point F, that means those two lines are equal to each other. So to solve this, I would say 4x minus 4 equals 3x and solve from there. That is all of the information you need to know with tangents. So 90 degrees, Pythagorean theorem, being able to set things equal to each other. Then let's look at 10.3, which is all about chords. So chords, really, again, is going to involve some Pythagorean theorem. So if I wanted you to solve for NM, and yes, this picture should look familiar because I pulled it off of your review study guide. If I ask you to solve for NM, we have a right triangle. I know this is 8, and then I want to know what this is. But you might look at this picture and say, I don't know what this measure is. Remember, if we have two chords, so in this case the two green lines are my chords, and they are the same distance away from the center, that means that they are congruent. Okay, so if this is 15, this is also 15. Redraw my right triangle. I have 8, 15. Solving for the hypotenuse, I have my a squared plus b squared equals c squared. Okay, that's pretty much all you need to know about chords. Moving on to inscribed angles. This is where you guys start to confuse yourselves. Remember, inscribed angles are when angles have a vertex on the circle instead of the center. So in this case, actually I'm going to switch the lines that I'm looking at. I'm going to look at this angle. So this 105-degree angle inside, the way it's related is it is 1/2 of the arc measure. Okay, so if I wanted to find that arc measure, I would do 105 times 2. 105 times 2 gives me 210. And then if I wanted to find A, I would just take away that arc measure right there. So I'd say 210 minus 95 and keep going from there. I do the same process in order to be able to find B. And then to find an angle inside, remember, you take the arc measure. So once you know what A and B are, once you know what these two arcs are, you can solve for angle C. Okay, and angle C is 1/2 of A plus B. Okay, if you need a refresher on that, come see me. I'm more than happy to help you. Lesson 10.5. This is where you guys really start to confuse yourselves and say, I've never seen a picture like this before. I don't know what to do. And then I usually say, go back to case 1, case 2, case 3. And then you kind of roll your eyes at me. But I say, no, really, it'll help you. And then you go back and look at this picture and it helps you. You need to memorize these things. It looks overwhelming, but look for the patterns. Okay, so first of all, if you have two lines that form an X inside of your circle and you're looking for an angle, take the two arcs that are formed by the vertical angle, add them together, divide by 2. Okay, you're basically finding the average of the two arc measures. Then, if your vertex of the angle is outside of the circle, the way you find the angle is it's 1/2 the large arc minus the small arc. That goes for case 1, 2, and 3. They just look slightly different. Now, the slightly trickier one, but still doable, is when you're dealing with segments. So again, if you have an X inside and you're looking for segments, you do W times X equals Y times Z. And I realize that this picture is really pixelated, so I'm sorry. But if you go back to the video, I have a much better version of this picture. Then, if we look at case 1, case 2 stuff, A times this whole length equals C times this whole length. That's how you solve for those segments. And if you just have one, because you have something that's tangent, you say that line that's tangent squared, so in this case that's V. V squared equals this line times the whole thing. So go back, make sure you know all of those formulas so that way this can be your reaction when you are done with your test. Okay? I think you all like to have that feeling. I like when you have that feeling. It's a win-win situation. But in all seriousness, if you have any questions, feel free to reach out for some help. And I'm more than happy to assist you. Happy studying.